Hey there, this is Darrick doing my chapter 16 homework video. One sec. Sorry, just closing my door. Okay, so let me just go ahead and get to the problems here. I kind of like this assignment. I feel like I understood the material a little bit better than normal. But at the same time as I was doing the homework, I realized that there were a couple of equations I kind of had written down wrong, didn't understand them fully, but the homework kind of helped me to piece them together. Anyways, first problem dealt with the curved bar, and then I had to find the acceleration of the rod and the reactions at A and B. So for this chapter, I did a really good job of drawing out the force diagrams, which really helps to understand the material. So right up here, question 1, sum of the forces in the y direction, sum of the forces in the x direction. Find that the acceleration of g is equal to 3.2 meters per second, because we have the weight, which is 2.5 times 9.8, plus the reaction at B plus the reaction at A. Acceleration of G. Is that it? Yeah. Okay, so now for the sum of the moments. So finding the sum of the moments at point B, which is the top point, we have 24.5 times the times 0.11 minus the force of A minus 3. And then we also use the equation, don't even using the whole time. Sum of the moments at a point is equal to IG, angular acceleration of the whole body, R cross M. Use that, knowing that R is negative 0.11 in the negative I direction, minus 0.19 in the j direction. Cross that by the acceleration, which is, or by the forces, I guess, because it is the force MA. So 8I plus 0j. Cross those, and I kind of went the long way. Got 1.52 in the k direction, positive, and then set that equal to the first equation that I made. So 1.52 is equal to 24.5 times 0.11 minus FA 0.3. I was able to find FA, which is 3.92 newtons, and then summing the forces in the y direction, I was able to find FB, which is 20.58 newtons. Okay, question number 2 had to do with the triangular frame that moves in the parallel curved slots. Okay, so for this one I had to find the acceleration and the reactions at A and B. So knowing that the angles for F of A and F of B, which is just the reactions, was 30 degrees above the horizontal, I was able to sum the forces in the x direction, sum the forces in the y direction, and then since we know the velocity as well, I was able to find the acceleration in the normal direction. One thing I really liked about this question was how we used an axis tilted, so that we had the tangential acceleration and the normal acceleration. So basically, knowing that the velocity was 30 and that the radius was 6 inches, we were able to find an acceleration in the normal direction, which is 12.5 feet per second squared. And then for the tangential direction, is that right here? Oh yeah, okay. In the tangential direction, using that tilted axis, FB, FA, able to find that it was 16 cosine 30, or 32.2 cosine of 30, which was 27.89 feet per second squared. So now that we know the two components, I was able to find the total acceleration in the x and y axis, or just finding the magnitude, adding the normal and tangential, which was 30.56. Found the angle relative to the horizontal, which was 84.15 degrees below the horizontal. And to find the reactions, I did the sum of the moments around B. So I was able to cancel out the force of, or the reaction of B. Found the moment of B using a cross product, which ended up being negative 13.64. Set that equal to the sum of the forces. So negative 13.64 is equal to negative 16 times 0.5 plus the reaction A times 0.75 sine 60. Found that the reaction of A was 6.5, 30 degrees below the horizontal to the left, and then the reaction of B was 31.61 at a direction of 30 degrees above the horizontal to the right. Okay, question 3 was the two wheels spinning, or the two discs spinning. I like this question. That helped me understand a few things. Okay, so first of all, I want to find, first of all, the angular acceleration of each disk and the final angular velocity of each disk. Okay, so first of all, I converted the 360 rotations per minute to radians per second, 37.7. Had to find the I of each disk. The I for a disk is equal to 1/2 mr squared, which is equal to 0.0192. Sum of the moments about P is equal to 0.0192 angular acceleration. Because we were able to cancel out the other half of the equation, since we use G as the point. Okay. So we have to know the friction of disk A, which is equal to normal, which is the 20 newtons, times the 0.15 given coefficient of friction, gives us 3 newtons. So we can find the moment about the center, which is equal to the 3 times the 0.08 radius of the disk, and then use that to find the angular acceleration. So 0.0192 divided by 0.24 gives us an angular acceleration for A of 12.5 radians per second squared. I did that one without using the solution. I was pretty proud of it. And then IB is 0.0054 using the same equation for I. And then the sum of the momentums around B is 0.0054 acceleration of B, which is equal to the sum of the momentums using the friction, which was the normal 20 times the coefficient of friction 0.15 times the radius of 0.06. Solve for angular acceleration, which is 33.33 radians per second squared. Looking at the solution, I found that sliding stops when angular velocity is equal to the radius of each disk. Since the angular velocity is equal to the angular acceleration times t plus the initial angular velocity, I was able to plug that in for each side of the first equation. So 0.08 radius times the 37.7 initial omega plus 12.5 t, which is the angular acceleration times t, is equal to 0.06 times the 33.33 angular acceleration of the smaller disk. Solve for t to find out when these are equal. T is equal to 3.016. Plug that into each of the equations to find the velocity at that time. Found that the angular velocity is 75.4 radians per second and 100.5 radians per second respectively. Okay, next problem. Had a drum and a disc. Had to find the combined radius of gyration of the disc and drum. I had a problem trying to understand the radius of gyration, but what I did for this one was I drew it out, had the 40 Newton. There we go, no more bending. Radius of gyration, force of tension, 40 newtons, and then 20 newtons at the respective radii of the drum and the disc. Sum the forces in the y direction. So 5, since we know that it's when we add them up, there's still a 5 Newton force upward. 5 is the mass. Sorry, 5 mass times the acceleration is equal to the 60 total tension upward minus the weight, gives us an acceleration of 2.2 meters per second squared upward. Upward. And then, since we know that the acceleration is equal to the angular acceleration times the radius, I was able to find that the angular acceleration was 11. Okay, so that means by using the sum of the moment about g, which was the 40 tension times the radii, or the radius, minus 20 upward times the radius, is equal to mass radius of gyration squared times the angular acceleration. It gives us a k equal to 0.17 meters. Okay, next problem, dealing with the bar hanging from a hinge at C. Okay, so this one was fairly simple. We have the weight, we have the force of the push, 75 newtons, the reaction of C in the x direction, reaction of C in the y direction, and then knowing that I for a bar is equal to 1/12 ml squared, found that to be equal to 0.27, and then found the sum of the moments about C is equal to 75 times the distance from the hinge C to the push is equal to I angular acceleration. I angular acceleration plus the R4 is the mass. So R M alpha. Solve for alpha. Found that to be 107.1 radians per second. Summing the forces in the y direction gives us a reaction of C. Reaction at C in the y direction is equal to 39.2. We know that mr alpha is equal to Cx minus 75. Plug in mr and alpha, solve for Cx, and we get 21.4 newtons in the negative x direction. Next question, the tires going down the hill. This problem kind of confused me because we're supposed to find the acceleration of the center of the wheel in terms of r, k, beta, and g. I was staring at this one for a long time because, I knew what each of the variables meant, I was having troubles trying to piece each one of these variables into the equation that I know. So, sum of the forces at C, mg sine beta, kind of tilting it and getting a tilted axis, gives us, we know what n would be, or the normal would be tilted in beta degrees to the right. So mg sine beta times the radius r is equal to mr squared alpha plus mk squared alpha. And then we're able to cancel out the m's, solve for alpha, and since alpha times radius is equal to acceleration, we're able to throw in r from what we had solved and found that the acceleration is equal to r g sine of beta over r squared plus k squared. It's simple, but it kind of had me beat for a while, so I was confused. Okay, problem number 7. So the drum and the disc, wanting to find whether or not the disc slides and the angular acceleration of the disc and the acceleration of g. You know I'm not just reading the solutions because I'm looking at my paper the whole time. Okay, so we know k is equal to 6 inches. We know the coefficients of coefficients of friction. I for a disc is equal to mk squared, radius squared. So found that I was equal to 0.0776. Okay, so we have I, so using the equations, sum of m at c is equal to -5.3 times 0.33 feet is equal to I alpha plus m r squared alpha. Solve for alpha gives us 7.75, and then we're able to find the acceleration is equal to 5.17, and that's assuming that it rolls, meaning that there's no friction force. That's what I had to understand from this. So that's how fast it would go, assuming that it rolls. So then we're able to find the force of friction, knowing that n is equal to 5 after summing the forces in the y direction. N is equal to 5. Force of friction, doing a static coefficient of friction gives us a 1.25 force for friction, and then using the coefficient of kinetic friction gives us a force of 1. So since both of those are less than the force given from the acceleration of a rolling drum and disc, we know that the disc must slide. So knowing that the disc slides, we add in the force of friction, summing the moment about c5 times 0.33 feet minus 0.6666 Newton feet is equal to 0.0776 alpha. Solve for alpha, 12.89 radians per second squared alpha, and then summing the forces in the x direction, which is just friction, which is 1, because it's a kinetic friction, is equal to ma, knowing a, divided by m. Find that the acceleration is 3.22 feet per second squared in the negative x direction. And then, yeah, I didn't do the last problem. I was just too tired and it was a little bit too complicated. Didn't finish it. Great. Well, thank you very much. Really nervous for the upcoming test. I feel like I understand the equations pretty well. Not perfectly. I'm a little nervous for it. I won't get a perfect score. But hey, gonna give it my best shot.